Good day, students and viewers. You are welcome to the studios of Maths X. We are still on the topic fractions, decimals, and percentages. On our previous video, we concluded with the first mathematical operation involving decimals, and that was addition and subtraction. In today's class, we will consolidate. We will we will go into the second mathematical operation involving decimals, which is multiplication, and also the third mathematical operation involving decimals, which is division. Happy viewing. So for our second mathematical operation involving decimals, we have two examples here to simplify. Now, if you watched my previous video, I did say that when you are adding and subtracting decimals, ensure that the decimal point is aligned. Arrange the numbers based on place values, aligning the decimal, right? But when it comes to multiplication, you don't need to observe that rule. Just go in and multiply and then count the number of digits after the decimal point for both expressions which you are multiplying. And then based on that number, do start your count from the left hand side of your solution. Then count backwards. That will ensure the location of the decimal point in your solution. In case you do not understand all I am saying, let me go into solution, then I will say it again. Most likely, it will make more sense to you, my dear students and viewer. So for my example, we have here 20.13 times 0.381. Did you observe that the decimal point is here and another decimal point is here? I did not need to align them when I am multiplying. So I just wrote them as they are. Of course, my sign is here, my multiplication, to show the whole world that I am multiplying. So here I go. 1 times 3 is a 3. 1 times 1 is a 1. 1 times 0 is a 0. 1 times 2 is a 2. That's for the first line. There will be a second line from the 8 and of course a third. So from this second line, from this second number here, you start your solution here. 8 times 3, that's 24. So 4 carry 2. 8 times 1 is 8, plus this 2 is 10. You have a 0 carry 1. 8 times 0 is 0, plus that 1 is 1. 8 times 2 is 16. So you have a 1, a 6, and a 1. Ensure that you place the numbers properly because any mix-up, you just won't get it right. The last number I'm using to multiply here is 3. 3 times 3, of course, the solution will be here on this line. 3 times 3 is a 9. 3 times 1 is a 3. 3 times 0 is a 0. 3 times 2 is 6. Pardon me going so low here, but this is what my answer will be. So you bring down your 3. I'm adding here. 1 plus 4 is a 5. 0 plus 0 plus 9 is a 9. I trust you are seeing from down here. 2 plus 1, 3. Plus 3 is a 6. 6 plus 0 is a 6. And then a 7. 1 plus 6. Now, watch what I'm going to do. The decimal point is here for the first number, 20.13. So I have 1, 2. I have 2 places of decimal. The decimal point is here for 0.381. So I have 1, 2, 3 places of decimal. So altogether, I have 5 places of decimal. And I'm going to start from the left-hand side, sorry, the right-hand side of my solution, count towards my left. So, and I'm going to count 5 numbers. After 5 numbers, I will place my decimal point. So that will be 1, 2, 3, 4, 5. So my decimal point will be here. So unlike addition and subtraction where you align the decimal, in multiplication, you just go ahead and multiply. When you multiply, you now count the number of digits after the decimal point in the numbers that you are multiplying. That will also reflect in your answer. Now that we know what to do, let's look at the B part of our example. For the B part, similar exercise or operation, we have 51.11. Notice the way I called it. I didn't call it 51.11, 51.11. These numbers are tenths and hundreds. So you don't call it 11 times 6.2. The decimal point is here and the decimal point is here. Of course, I'm multiplying. 2 times 1 is a 2. 2 times 1, another 2. 2 times 1 is a 2. 2 times 5 is a 10. That's 1 and 0. 6 times 1 is 6. 6 times 1 is 6. 6 times 1 is 6. 6 times 5 is a 30. So we have 2, 8, 8, 6, 1, and 3. So my next resolve is to count the number of digits after the decimal points. We have 1, 2, and a 3. So we start from our right hand side to count down. So 1, 2, 3. So the decimal point is here. So here my answer was 7.66953. This is a 5, not an S, please. 7.66953. Here our answer is 316.882. So those are our solutions to multiplications of decimals. I trust you should not have too much problems doing this. Let us go to our third mathematical operation involving decimals, and that is what? Division of decimals. This will be interesting for us, trust me. So number 3, division of decimals. Our third mathematical operation involving decimals, which is division of decimals. The first exercise here says convert the fraction to decimal, and that fraction is 130 divided by 25. Our second example here is simplify 2011.6 divided by 20.8. I hope our decimal point is clear. Then lastly, but of course not the least, we have evaluate 0.016 times 0.084 all over 0.16. Let's make the decimal points clearer or more visible because I need them. 0.16 times 0.48. I trust you have seen what I am doing. So for our first example, convert the fraction to a decimal, and the fraction is 130 over 25. For me, the first thing I would do is to take them down, as in cancel, using 5. 5 here is 5. 5 into 13 is 2 times. That is 10. Remainder 30. 5 into 30 is 6. So what I have here is 26 over 5. With this is an improper fraction, and mathematically it is not right to keep your answer as an improper fraction. And again, the answer talks about what? A decimal, that convert the fraction to a decimal. So I need to take this down. To do this, I will have 5 into 26 is 5 times remainder 1 over 5. I just converted an improper fraction rather to a mixed fraction. But they are still fractions. The answer talked about a what? A decimal. So the mixed fraction has a whole number and a fractional part. So it is this fractional part I'm going to convert to decimal. And I'm going to do that using a long division. I know the answer already, but my dear students and viewers, all of us need to be on the same page. So I will take the fractional part, which is the 1 over 5. 1 over 5 technically means 1 divided by 5. So I'm going to use this fractional part in a long division exercise. So here we go, my long division. That's what we call it here in Nigeria. I don't know what people call it in that part of the world where you are watching from, but this is what we do here. So we have a 5 as my divisor and a 1 as the number to be divided. So 5 into 1, that is not possible, cannot. That will be a 0 and a point on that. And when you place that, 0, 0 and 0 cannot, you write here a 10. Now 5 into 10 is what? 2. 2 times 5 is a 10 and a 0. So our answer will now be 5.2. So this is a number in decimal. 5 whole number 1 over 5 was a mixed fraction. 26 over 5 was an improper fraction, but 5.2 is a decimal number. There should have been a 5 here, please. A 5 plus whatever you have here. So my answer here, 0.2, is now 5.2. So there is a 5 actually being added here. So this 5 is this particular 5 here. This 5 is the divisor, the denominator. And there was a 1 here. I guess I missed that. So that is it. Let's look at a second solution. Solution, which is this. That 2011.6 divided by 20.8. To solve this particular fraction, I do advise my students, as much as you can, avoid decimals in divisions. Try and make your numbers a whole number. It will serve you better. Because in my experience, I found that the decimals do tend to confuse many students when they are trying to divide with it. I've seen that several times. So to make these expressions, this fraction, a whole number, of course, the numerator is 2011.6. The denominator is 20.8. And there is one digit after the decimal point for the numerator and denominator to ensure that these numbers are now whole numbers. You will multiply the numerator by 10 as well as the denominator by the same 10. The idea now is to turn them to whole numbers, and at that level we're going to have 20,116 over 208. That's what we have here. Technically, looking at this expression, 10 over 10, 10 over 10 can cancel, and you have 1, right? So it means 1 times this expression, it will still be this expression. So you've not done anything extra, nothing new. It's just a small trick of making these numbers a whole number. Looking at these numbers again, they are both divisible by 2. I believe 4 can do some justice here also. So let's start with a 4. 4 here, 5. 4 here, 2. 4 here, 5. 4 into 1 cannot, that's a 0. 4 into 11, that is 2 times 8, remainder 3. 4 into 36, that is 9 times. So I have 5,029 divided by 52. I'm still going to be using my long division. So my 5,029 divided by 52 will be, by long division, this will be 52 as my divisor. This is the number to be divided. So we have 5,029. Now, let's be smart about this. 52 into 50 cannot, so you won't take that. No. But 52 can surely go into 502 with some remainders. Let's be a bit smart. If you say 52 times 10, you're going to have 520, which is bigger than 502. So in my mind, mentally, I believe the best number to use will be 9 in multiplying 52 to have something close. Let's do a rough. That will be 52 times 9. So we have 8, carry 1. That's 9 times 2 is 8, carry 1. 9 times 5 is 45, plus that 1 that was here, which is what? 46. This is close, because if you use 10, it won't work. So let's use 9 as our first quotient. So this is 468. We subtract. Borrow 1 from the 5 here, we have 4 here, there's a 10 here. Borrow 1 from the 10 here, we have a 12 here. So 12 minus 8 is 4. 9 minus 6 is 3. So we have 34. Of course, this will be a 0 here, so no point in writing a 0 in front of your 3. So we have 34 here. 52 into 34 cannot. So you will bring down 9. I'm aware that 52 times 9 is 468. Let's try a 7. So 52 times 7. 7 times 2 is 14. Carry 1. 7 times 5 is 35, plus that one is 36. Hey, 364. 349. This is bigger. Then 6 is the number to be used. So I have a 6 here. So 6 times 2 is 12. Carry 1. 6 times 5 is 30. Plus that one is 31. I'm subtracting. So we have a 7 and a 3, 37. So our answer based on this will be 96 whole number, 37 over 52. So we just used our long division process in this. Let's try the C part of our division. In the C part, we're going to use more of this. Earlier, my dear students and viewers, when I was solving the B part, I did emphasize on the need to make our numbers whole numbers when we are dividing, because it does confuse students a lot. So that's what I'm going to do. But there's a little caution we need to take here, because this particular division is not like this one. Here we had one decimal point in the after the one digit after the decimal point for both the numerator and denominator. But here is not so. Here we have 1, 2, 3, 1, 2, 3. So we have 6 digits after decimal points in the numerator and 4 digits after the decimal point in the denominator. So I require a number with 6 digits in the numerator to make the numerator whole numbers. I require a number with 4 digits in the denominator to make the denominator a whole number. So there's a disparity there. And if I multiply the numerator with a number that has 6 digits, and I multiply the denominator with a number that has if I multiply the numerator with a number that has 6 zeros, which is a million, and I multiply the denominator with a number that has 4 zeros, which is 10,000, I will end up setting questions for myself. I'm the one setting my own questions. That's not what I was given. So one thing with mathematics is that whatever you do to the numerator, do well to do the same to the denominator. Ensure that if you're using 10, a number with 10 zeros to multiply both the numerator and denominator, keep it that way. Don't use a number with 6 zeros to multiply the numerator and then use a number with 4 zeros to multiply the denominator. That way you've changed everything. You are setting questions for yourself. So ensure that what you do to the numerator is the same operation you are doing to the denominator. Very important. So I would do this. I would multiply the numerator by 1 million and also multiply the denominator by another 1 million. That way they can cancel. It looks as though I am multiplying this whole expression with what? 1. Yes. So do be careful with that. When I do that, there will be excesses, especially in the numerator, but it doesn't really matter. The whole thing is just make sure you are doing the correct thing. So when I multiply the numerator with 1 million, I will have 16 times 84 all over. When I multiply the denominator with 1 million, I'll have 16 times 48 times 10 to the power 2, which is 100. I can go on. Here, 16 cancels 16. That one is easy. Then 6 here, 6 here, 8 times, 6 here, 12 times. Again, 4 here, 2 times, 4 here, 3 times. So what I have here is 3 over 200 as my final answer. So I choose to keep this as a proper fraction. No point in going into the decimal aspect of of the answer. All right. So my dear students and viewers, this is the much we can take in today's class. In our next video, we will go into percentages, and hopefully we're going to end up concluding this particular topic. I just want to thank you all for giving me ears. Keep liking, keep watching the videos of MathsX. Like, share, and subscribe. As you do so, God bless you. We love you.